So everything in Chapter 3 up to 3.5 have been talking about polynomial equations. And 3.5, we're going to shift gears just for this very last section of Chapter 3, and we're going to talk about rational functions. So rational functions, as we've discussed before, are a ratio, right? It's a fraction where the numerator is a polynomial and the denominator is a polynomial. And that's why it gets included in this chapter, is because it is still discussions of polynomials, but it's polynomials put into a fraction. So there's a couple of things we're going to do at the beginning of this section, and that's where we'll look at today. In particular, we're going to look at domain, and we're going to look at asymptotes. So domain, first, has to do with x values, as you know. We've talked a lot about domain already this semester. And in particular with rational functions, what we're looking for is we're looking for locations where the denominator could be 0, because we cannot divide by the number 0. So if I were to look at this particular function, -1 over x minus 2, what x value could I not have? 2, right? X cannot be 2, because it'd make the denominator 0. So if I were listing the domain in a positive way, instead of saying what it can't be, I'm saying what it can be, it would include everything from -infinity to 2, with parentheses, union from 2 to infinity. And this would be my domain. Does that make sense? You're just saying what x can be as opposed to what x cannot be. Now the second denominator, number 2, is not just a simple x minus 2. It's going to have to be factored, right? Now we're going to set it equal to 0 to factor it. How will x squared plus x minus 12 factor? +4 and -3, or -3. Yes, very good. And you might say, well, what about the numerator? Well, in terms of domain, it's irrelevant. It does not affect the domain. It's going to affect something else real soon, but it does not affect the domain, okay? So if all I'm asked for is the domain, all I care to factor is the denominator. And if I set each of the pieces of the denominator equal to 0, because I know those are things that are not okay, x plus 4, what value can x not be? -4. So x cannot equal -4. How about the x minus 3? Yep, +3 is a no-go. So these are two values that I cannot have. And of course, if you're thinking about a number line, -4 comes first, +3 comes second. So again, listing the domain in a positive sense, what is the domain actually able to be as opposed to not able to be? It would start on the -infinity, far left, and it would go until I get to -4. I need to make sure I include the values between -4 and 3. So union -4 to 3, parentheses and everything, and then from 3 on. So this would be my domain. Okay, does that make sense? Okay, two types of asymptotes that we are going to look at specifically. The first type of asymptotes, the easiest one, and it's the one most directly related, back to what we just did. It's vertical asymptotes. So vertical asymptotes. So we've talked briefly about asymptotes before, but not in any kind of full discussion. An asymptote is a line that we get really close to and that we don't touch. So in terms of a vertical asymptote or a graph, let me just sketch a graph so that we have a reference point for discussion. And vertical asymptote would be what's happening right here in the middle, roughly here. I'll move it over so it's actually closer to it. It's this vertical line that these edges that are swooping up and swooping down, they don't have to swoop in this way or at this location, but that's a vertical asymptote. It's a vertical line that it's really approaching, and it's getting infinitely large, in this case on one side, and infinitely small on the other side. So right now, what we're looking for is this type of an asymptote. It's a vertical one. And in a vertical asymptote, this happens if a rational function in its lowest terms, we'll talk about that in just a second, has a denominator where it can actually equal 0. So if we go back to the first equation that we were dealing with over here, -1 over x minus 2 is in its lowest terms. I can't factor the numerator and reduce it with anything in the denominator, so it is in its lowest terms. And that same location that I can't have in the domain, namely 2, right, creates my asymptote. So my asymptote from problem number 1 is x equal 2. So in a very real sense, the location where I said it can't equal 2 is the location where the vertical asymptote is happening. Problem number 2 is not quite so straightforward. The problem with problem number 2 is that we only factored the denominator, and we did so with good reason. Remember, the denominator is what creates domain issues. That's fine, but it doesn't necessarily create asymptotes. Not only can you create asymptotes with zeros in the domain, you can also create holes in the graph as zeros in the domain. So while your calculator might not show it, this graph could have had a gap right there, for example. And that could also happen when the denominator is equal to 0. So how do we know if there's an asymptote or there's a hole? We know by getting it into its lowest terms. So as we go back and look at problem number 2, now we are going to factor the numerator. Now, first thing, got that negative out in front. I saw that back in section 3.4, and I didn't like it then, and I don't like it now. That negative in front makes things difficult for factoring purposes, so the first thing I'm going to do is to take it out. It changes all my signs on the inside. Okay, so far so good? So what we want to do now is we want to factor this piece. So I've got the negative in front, and I've got my 2 sets of parentheses, and these are both x's. My sign at the end is positive, so my signs will match. My sign in the middle is negative, so they're both negative. I need 2 numbers that multiply to 3 and add to -2. Is that what it was? Yeah, 2 numbers that multiply to 3 and add to -2. Okay, so -3 and +1 would do that, but then it would give me a -3 at the end instead of a +3. So those won't work. What's that?
Would just be the opposite.
Opposite like what?
Positive 3.
But I can't change my signs, because if I change either of my signs, I will get a +3. I will get a -3 here instead of a +3 here. My signs can't switch. I have to have the signs both negative. Say that louder, Tiffany. You're right, so say it louder.
No, I didn't even say anything. I just said this is the negative of the front. Where did you do that? You can't.
Okay, you can't. You're right, you can't. If I were to take the negative and I were to distribute it back through, like if I tried factoring this as is, it would be very difficult, but I could, and I would still end up with the same problem. I'd have a -x and a +x, and now I need a -3 and a +3. I'm still not going to be able to get it to work. It doesn't work. It doesn't factor. If I were to try to solve this and set it equal to 0, I'd need the quadratic formula to do so, or completing the square. But it doesn't factor. So why does that matter? Well, what matters is that that means it doesn't have either of these places that it creates a factor in the numerator. I don't have a factor of x plus 4 or a factor of x minus 3 in my numerator. Agreed? Okay. What does that tell me? Well, it tells me that my original equation was already in reduced form. There's no factors in the numerator that cancel with factors in the denominator. So why does that matter? Well, it creates a vertical asymptote at both of those values. -4 and positive 3. So I have 2 asymptotes. In fact, I do. If I had had, and we'll see next time because we're about to pause right here, if I had had something, say, like x minus 3 in the numerator, let's say it really did factor in some fashion. I'm just making things up right now, so don't necessarily need to write this down, but we're going to see it tomorrow. If it had had this form, when it factored, right, even if the negative in front, I don't care, it doesn't matter, the x minus 3's would have matched. And if that had happened, I would have had a hole in the graph at x equals 3 instead of an asymptote at the graph at x equal 3. Okay? That's what we're looking for when we're saying, does it factor on top? Does it reduce with anything on bottom? We're trying to decide, are there really 2 asymptotes from the bottom, or does one of them get eliminated and become a whole? All right? This one, there was no eliminating, so I did, in fact, have 2 asymptotes. Okay, so we're going to stop here because vertical asymptotes are pretty straightforward. I know it was weird because you're like looking for factors, but horizontal asymptotes are a little more complicated, so we'll pick up there next time.